Okay, so I believe many of you have joined. Five people, five, six people have joined. Okay, start the class. Okay, so good evening, everyone. This is the last live session of Geotechnical Engineering, week 12, and the topic of today's discussion is settlement of compressible soil layers. Before starting, I want to confirm from you something. Have you received any mail or being communicated by any way that of any extra class tomorrow, extra live session, discussion session tomorrow?
Not yet, sir.
Okay. So generally, when do you receive the mail? The previous evening, right? The mail you received the previous evening about the live
Yesterday we got
discussion.
a mail, but it was about examination, sir. NPTEL
No,
final exam.
no. Regarding this live discussion, you people get a weekly mail, right? On Friday that tomorrow there will be a
Yes,
live
sir.
discussion.
Yesterday evening we got, and on WhatsApp also.
Yes. So when, what is the time that when do you receive that mail?
Mhm.
At what time do you receive that mail? In the evening, right?
Yes, sir.
Okay. Okay. Fine. Okay. So I have opted for an extra 1 hour discussion class tomorrow. I don't know whether the time will be feasible or not, but they have told me that there will be a discussion class. Okay. So leave that. We'll be starting our discussion today. So as uh, every week's class, just a moment. Just one moment. Yeah, sorry for the interruption. Okay, so the topic is settlement of compressible soil layers. Those of you who have attended the previous live session, I believe it was on consolidation, right? Shakir, you are there, right?
Yes, sir.
Yes. So this is an extension of the previous chapter where I'll be discussing on only the settlement, the concept of settlement. Okay. And since I've already talked about the concepts of consolidation giving MCQs in the last class, this class has less number of MCQs and more number of numericals. There are 12 numericals over here. Okay. So I'll be starting the statement, filling the questions right now, and I'll give you some time to solve the answers. Okay. Okay. So the first question, right? Write down the questions now. The ultimate settlement of soil is a function of. The ultimate settlement of soil is a function of. The options are coefficient of volume change, increment in effective pressure, thickness of soil layer, or all of these. Yesterday I received first time mail to interact live sessions. Okay. But these live sessions have been going on for like, this is the 12th live session. So I don't know why you have received only the last classes. I mean, it's okay. You can find out you can find the PPTs and recorded live sessions. Okay, next question. Settlement of a soil layer at any time with respect to the ultimate settlement yields. Settlement of a soil layer at any time with respect to the ultimate settlement yields. The options are coefficient of volume change, degree of consolidation, coefficient of compressibility, or coefficient of permeability. You can turn off your video. Settlement of a soil sorry, settlement of a soil layer at any time with respect to the ultimate settlement yields. The options are coefficient of volume change, degree of consolidation, coefficient of compressibility, coefficient of permeability. Next question. Consolidation settlement can be computed by using coefficient of volume change, Boy's ratio, both of these, none of these. Pattern of examination of NPTL. I will not be setting the question. I'm sorry. That I think will be set by your course coordinator, DN Singh sir. I'm just here to help you with the live discussions and practice questions so that you can solve the questions in a better way. Consolidation settlement can be computed by using coefficient of volume change, Boy's ratio, both of the above, none of these. Next question. Final settlement is small in case of pre-consolidated soils as the recompression index is very small compared to compression index. I repeat the question. Final settlement is small in case of pre-consolidated soils as the recompression index is very small compared to the compression index. Is this statement true or false? You have to state. Final settlement is small in case of pre-consolidated soils as the recompression index is very small compared to the compression index. True or false? Okay, next question. From here, the numericals are starting. A fully saturated clay specimen is placed in a consolidometer and 2 kg per centimeter square load is applied. After some time, the pore pressure is found to be 0.6 kg per centimeter square. Find the corresponding value of settlement if the ultimate settlement is going to be 20 millimeter. Read the question first and tell me if you have any doubt. Sir, I missed live session, but follow you on your YouTube channel. It's okay, it's fine. You can you can learn from the videos only, and if you have any doubt, you can tell me now, or you can leave any comments on that particular video. Okay, good. A fully saturated clay specimen is placed in a consolidometer and 2 kg per centimeter square is applied. After some time, the pore pressure is found to be 0.6 kg per centimeter square. Find the corresponding value of settlement if the ultimate settlement is going to be 20 millimeter. Next question. A settlement analysis carried out for a proposed structure indicates that 9 centimeter of settlement will occur in 5 years, and the final settlement will be 45 centimeter based on double drainage condition. A detailed site investigation indicates that only single drainage occurs. Considering the degree of consolidation to be less than 60%, estimate the settlement at the end of 5 years for the changed condition. Read the question very carefully and then write it down. If you have any doubt, you can ask me. A settlement analysis carried out for a proposed structure indicates that 9 centimeter of settlement will occur in 5 years and the final settlement will be 45 centimeter based on double drainage condition. A detailed site investigation indicates that only single drainage occurs. Considering the degree of consolidation to be less than 60%, estimate the settlement at the end of 5 years for the changed condition. Have you copied the question? Have you finished writing the question?
No, sir.
Okay. Tell me when you're done.
Done, sir.
Okay. Next question. A clay layer 8 meter thick is subjected to a pressure of 70 kN per meter square. If the layer has double drainage and undergoes 50% consolidation, this time factor equal to 0.196 in 1 year. Determine the coefficient of consolidation. If the coefficient of permeability is 0.040 meter per year, determine the settlement in 1 year. Take the unit weight of water as 9.81 kilonewton per meter cube. So first you have to determine the coefficient of consolidation Cv, and then find out the settlement in 1 year. Okay, it has been said that it undergoes 50% consolidation in 1 year. So the thickness is 8 meter, the pressure to which the layer has been subjected to is 70 kN per meter square. TB is given over here for 50% consolidation. TB equal to 0.196 and K 0.04 meter per year. Take gamma W equals to 9.81. I repeat the question once. A clay layer 8 meter thick is subjected to a pressure of 70 kilonewton per meter square. If the layer has double drainage and undergoes 50% consolidation, time factor equal to 0.196 in 1 year, determine the coefficient of consolidation. If the coefficient of permeability is 0.04 meter per year, determine the settlement in 1 year. Take the unit weight of water as 9.81 kilonewton per meter cube. Any doubt regarding this question? I hope you have finished copying the question, right?
Yes, yes.
Yeah, okay. Next question. A soft, normally consolidated clay layer is 20 meter thick with a moisture content of 45%. Clay has a saturated unit weight of 20 kilonewton per meter cube, a particle specific gravity of 2.7, and a liquid limit of 0.6, liquid limit of 60%. A foundation load will subject the center of the layer to a vertical stress increase of 10 kilopascal. Groundwater level is at the surface of the clay layer. Estimate number 1, the initial and final effective stresses at the center of the layer. Number 2, the approximate value of the compression index. And number 3, the consolidation settlement of the foundation above the layer. Take unit weight of water as 10 kilonewton per meter cube. I repeat the question. A soft, normally consolidated clay layer is 20 meter thick with a moisture content of 45%. The clay has a saturated unit weight of 20 kilonewton per meter cube, particle specific gravity of 2.7, and a liquid limit of 60%. A foundation load will subject the center of the layer to a vertical stress increase of 10 kilopascal. Groundwater level is at the surface of the clay layer. Estimate number 1, the initial and final effective stresses at the center of the layer, the approximate value of the compression index, the consolidation settlement of a foundation above the clay layer. Take unit weight of water as 10 kN per meter cube. Have you copied the question?
1
Hello?
minute, sir.
Yes?
Sir, 1 minute.
Done?
Yes, sir.
Okay. I want to tell you one thing before. There is a network issue going on over here. So, in case I get disconnected from this meeting, okay, do not leave the call. Okay. If I get disconnected, do not leave the call. I'll be joining right away. Again. Clear?
Yes, sir.
So this question has been done. Yes. Yes, question. A 20-meter thick clay layer is sandwiched between a silty sand layer and a gravelly sand layer and experiences 30 mm settlement in 2 years. If the coefficient of consolidation of the layer is 0.003 centimeter square per second, calculate the extra time required for the soil to achieve a total of 50 mm settlement. Please write fast. I repeat the question. A 20-meter thick clay layer is sandwiched between a silty sand layer and a gravelly sand layer and experiences 30 mm settlement in 2 years. If the coefficient of consolidation of the layer is 0.03 centimeter square per second, calculate the extra time required for the soil to achieve a total of 50 mm settlement. Done? Yes, Sai Krishna. Any query?
Done, sir.
Sai Krishna, do you have any query? Next question. The average effective overburden stress on 10-meter thick homogeneous saturated clay layer is 150 kilopascal. Consolidation test on an undisturbed soil sample taken from the clay layer showed that the void ratio decreased from 0.6 to 0.5 by stress increment from 100 to 300 kilopascal. Calculate number 1 the initial void ratio of the clay layer, number 2 the total consolidation settlement of the clay layer due to construction of a structure imposing an additional stress intensity of 200 kilopascal. So you have a soil layer which is 10-meter thick. The effective stress initially was 150. Now in the laboratory during the consolidation test, the void ratio decreased from 0.6 to 0.5 and stress was increased from 100 to 300. Using that you can find out the initial void ratio, and then you have to find out the settlement of the layer due to an additional stress increment of 200 kilopascal. The average effective overburden stress on 10-meter thick homogeneous saturated clay layer is 150 kilopascal. Consolidation test on an undisturbed soil sample taken from the clay layer showed that the void ratio decreased from 0.6 to 0.5 by stress increment from 100 to 300 kilopascal. Calculate number 1 the initial void ratio of the clay layer, number 2 the total consolidation settlement of the clay layer due to construction of a structure imposing an additional stress intensity of 200 kilopascal. Done? Copying the question. Shall I go to the next question?
Yes, sir.
Okay. Next question. At a given site A, having a clay layer 8-meter thick with single drainage, a uniform fill that was constructed resulted in a settlement of 5 centimeter in 1 year, corresponding to 50% average degree of consolidation. It was found that at a neighboring site B, the same type of soil exists, but the thickness is 16 meter. How long will it take for 50% consolidation to occur, and what will be the magnitude of settlement if a fill of the same magnitude as at site A was to be constructed at site B? I repeat the question once. At a given site A having a clay layer 8-meter thick with single drainage, a uniform fill that was constructed resulted in a settlement of 5 centimeter in 1 year, corresponding to 50% average degree of consolidation. It was found that at a neighboring site B, the same type of soil exists, but the thickness is 16 meter. How long will it take for 50% consolidation to occur, and what will be the magnitude of settlement if a field of the same magnitude as at site A was to be constructed at site B? I hope the question is clear. If there isn't doubt, you can ask. You write fast, otherwise you won't get time to solve. Have you finished writing the question? Shakir,
Yes, sir.
it is done, right? The question is, hello? The question is copied, right? Shall I go to the next question?
Yes, sir.
Okay, fine. Yes. A layer of normally consolidated saturated clay of 1 meter thickness is subjected to one dimensional consolidation under a pressure increment of 20 kilopascal. Pressure increment, okay, mind it. The soil has specific gravity of 2.7, natural moisture content of 45%, compression index of 0.45, and decompression index of 0.05. The initial average effective stress within the layer is 100 kilopascal. Determine the primary consolidation settlement of the soil layer. I repeat the question. A layer of normally consolidated saturated clay of 1 meter thickness is subjected to one dimensional consolidation under a pressure increment of 20 kilopascal. Soil has specific gravity 2.7, moisture content 45%, compression index is CC equal to 0.45, and decompression index CS equal to 0.05. The initial effective stress within the layer is 100 kilopascal. Then find out the primary consolidation settlement of this soil layer. Done?
Done, sir.
Okay, good. Next question. A 4-meter thick, normally consolidated clay has an average void ratio of 1.3. Its compression index is 0.6 and coefficient of consolidation is 1 meter square per year. If the increase in vertical pressure due to foundation load on the clay layer is equal to the existing effective overburden pressure, calculate the settlement of the clay. So a soil has been given, normally consolidated clay, thickness is 4 meter, the average void ratio is 1.3, compression index is 0.6, and CV, that is the coefficient of consolidation, is 1 meter square per year. Now it is being said that the increase in the vertical pressure is equal to the existing vertical pressure. Then find out the settlement of the clay layer. Tell me when you have finished copying the question. Shall I go to the next question? Hello?
Yes, sir.
Yeah. In a consolidation test, the void ratio of the specimen, which was 1.068 under the effective pressure of 214 kilonewton per meter square, changed to 0.994 when the pressure was increased to 429 kN per meter square. Calculate the coefficient of compressibility, compression index, and the coefficient of volume compressibility. Find the settlement of foundation resting on the above soil if the thickness of the layer is 8 meter and the increase in pressure is 10 kN per meter square. So, the data given is of a concentration test in which the void ratio of specimen was 1.068 under a pressure of 214 kN per meter square, and then it changed to 0.994. The void ratio changed to 0.994 when the pressure was increased to 429, increased to, not increased by, okay, the final pressure increased to 429 kN per meter square. Using this data, you have to first find out the coefficient of compressibility, that is AB, compression index, that is Cc, and the coefficient of volume compressibility is Mv. Then you have to find out the settlement given that the layer has a thickness of 8 meter and the increase in pressure in that layer of soil is 10 kN per meter square. Okay. Let me know when you are finished. There are two more questions left.
Done, sir.
A normally consolidated clay settled by, okay, I'll repeat it. Settled by 2 centimeter. Normally consolidated clay settled by 2 centimeter when the effective stress was increased from 100 kilopascal to 200 kilopascal. Calculate the settlement when the effective stress is increased to 400 kilopascal and 800 kilopascal. So you have a clay layer where the initial stress was 100. Upon increasing the stress to 200, the settlement observed was 2 centimeter. Now you have to find out in two cases the settlement. One, when the pressure was increased to 400 kilopascal, and then pressure was increased to 800 kilopascal. Okay. Done?
Yes, sir.
Yeah. Next question. The last question. A saturated soil has a compression index of 0.28. The void ratio at a stress of 12 kN per meter square, sorry, is 2.05, and its permeability is 35 into 10 to the power minus 7 mm per second. Calculate the change in void ratio. The stress is increased to 21.6 kN per m square. And number 2, the settlement in the first case, there is 1, the soil is 6 meter thick. Done? Copying the question?
Yes, sir.
Okay. So I believe all of you have copied all the questions, and I believe you have 12 numericals, 12 sums. Isn't it? Shakir, you have 12 sums, right? 12 numericals and 4 MCQs. Hello?
Yes, sir.
Okay, okay. I'll give you time 15 minutes. I'll start around. Okay, I'll start around 6:05. Okay. Will it be okay for you to solve all
Hello.
the questions? I need more time.
Hello.
Yes, hello.
Yeah, I have not studied the first time. Even I'm
What?
thinking almost. I can't do even not a one numerical from this. If you take more time, sir, if you explain us in better manner.
You can't solve any sum from this chapter.
I have not studied without the settlement part. I have studied that one, but without settlement.
Okay, 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 okay. Then I'll start at 6 o'clock, 6:05 around that time. You try to solve. Okay. Whatever you can, you try to solve. Okay.
Yes, sir.
Okay. At 6:05, I'll start discussing the answer. Clear?
Yes, sir.
Okay. Yeah. Fine. Hello,
Yes, sir.
am I audible? Can we start discussing the answers now?
Yes,
Okay, just a moment. Yeah. Okay. First question was the ultimate settlement of soil is a function of. What is the answer, Shakir?
sir. All of
Yes, all of this because the formula is rho equals to mv del sigma h. Right. mv is the coefficient of volume compressibility, del sigma is the increment in the effective stress, and h is the initial thickness. So yes, ultimate settlement is a function of coefficient of volume change, increment in
sir.
pressure,
You
and
write this
thickness.
formula, yes, sir.
Formula I'll write over here. Ultimate settlement if you consider
Yes, sir.
rho f final settlement, that will be equal to mv del sigma h. H means h0. mv is the coefficient of volume change, increment effective is del sigma, thickness of solid is h0. So this is all of this. Okay, clear? Next question. Next question. Settlement of soil layer at any time with respect to the ultimate settlement yields. What is the answer? What is the answer? Shakir. It is degree of consolidation. Okay. Settlement of soil layer if it is rho with respect to the settlement ultimate settlement. That is the ratio into 100. Give us what? U. Okay. Okay. Next question. Consolidation settlement can be computed by using. What is the answer? Hello? What is the answer? Do you know the answer?
Sir.
It is both of the above. Okay. Using MB also you can find out. Using void ratio also you can find out. You'll see in the upcoming numericals. You'll see. Okay. Final settlement is very small in case of pre-consolidated soils as the decompression index very small. This is what? This is a true statement. Okay. This is a true statement because settlement is a function of compression index. Okay. The function of compression index. Whether it is compression index or recompression index. Now recompression index CS is generally 1/5 to 1/10 of CC. So in case of pre-consolidated soils, The final settlement is less because CS is very much less than CC. Okay,
CC.
CC is the compression index and CS is the decompression index or the swelling index. Okay, you can check the graph for this. Okay, load versus E graph. As the load is increasing,
And 1 by 5th to 1 by 10th of
CC, this is CC. Okay, if this is the sigma, this is the load, and this is E. At first decreases, then you release the pressure, then it increases like this, then it follows this path, and then it again decreases. So
yes, sir.
this is the what? This is the decrement in decrease in the void ratio. This is the compression index, and this is the increase in void ratio. This is the swelling index. So pre-compression means pre-consolidated. It was previously consolidated, and then it was then it swelled to a certain extent, and then it was consolidated again. So CC, you can see the slope is very less than this line. So CS is less than CC. Okay, and hence band settlement is very small in case of pre-consolidated soils. Clear? Next question.
Yes,
Yes. So I have solved one question like this in the previous class. It was the degree of consolidation was asked over there, but now it is the settlement. Now we know that effective sigma is equal to, at certain point of time when the pore pressure is 6.6 was equals to 2 minus 0.6, that is 1.4, right? 2 minus 0.6, it is 1.4 kg per cm square. Finally it became what? At the ultimate settlement there will be no pore pressure, right? So it will be 2 only. So at the ultimate settlement, at the ultimate moment, the settlement will be rho f, which is equals to 20 mm. Now we know degree of consolidation equals to rho by rho f, and also degree of consolidation equals to effective stress at that point of time by the final effective stress. From this you can find out the value of rho, that will be equals to sigma by sigma f into rho f. What is sigma? Sigma is 1.4 divided by sigma f is 20, final effective pressure. Sorry, not 20, it's 2. 2, it is 2 into rho f. Rho f is 20, isn't it? So you can find out 2 into 10, 20, 1.4 is 14. It will be equals to 14 millimeter. So at that point of time when the pore pressure was 0.6, okay, the ultimate settlement was 14 millimeter. Okay, and that will be obviously corresponding to how much? 14 by 20 into 100, that is 70% of degree of consolidation. Clear?
repeat. Repeat this once again.
Degree of consolidation is what? Sigma by sigma final, right? Effective stress at certain point
Okay.
of time by final effective stress. Also
Final.
degree of consolidation is what? Degree of consolidation is settlement at certain point of time by ultimate settlement. So okay, so I will be using
Okay.
this part of the equation. I will be using this part of the equation. I need to find out the rho at this point when the pore pressure was 0.6. So rho equal to how much? Rho equal to sigma dash by sigma f dash into rho f, isn't it?
Yes, sir.
Into rho f. So rho equals to how much? I think this is wrong. This will rho. Rho equals to how much? Rho equals to sigma by sigma. That is 1.4 by 2. 1.4 by 2 into 20. That is giving me 0.6. Clear?
And this is the sigma f here, yeah? Yeah, rho f, sorry.
This is rho f, and this is rho, not f. Okay. Just a minute. Everything is coming like this. This is not f. Okay, this is rho.
Yeah, I got it.
Is there an eraser? Yes, I believe there is. Stroke eraser. Okay, this is rho. Rho equals to 1.4 by
Yeah,
220. Yeah. Okay. Someone has joined. This question, I believe you haven't solved any question, right? Have you solved any question?
sir, your voice is breaking.
Have you solved any question?
The last three.
Last three of solved. This one you haven't solved.
No, sir.
Okay. So what we have to do over here, settlement analysis carried out from a structure, 9 centimeter will occur in. Okay. So first we were under a misconception that it was double drainage. Okay. So U in the first place will be equals to how much? Rho by rho f into 100 to find out the degree of consolidation. Rho is how much? 9. It is how much? 45. That is equals to 20%. 20% is the degree of consolidation. Okay. Now you have to find out. See, you have to find out like this. TV time factor for 20% consolidation equals to obviously CBT by for double drainage is how much? Double drainage is h by 2 whole square, right? Double drainage is h by 2 whole square. Like this, we
Yes,
can
sir.
find out the value of CB by h square. CB by h square. Time is how much? Time is 5 years. You have to convert that 5 years into days, then hours, then minutes, then seconds. Like this, you can find out the value of CB by h square. Because CB is unknown and also h is unknown, we cannot find out that. So we have to find out the value of this parameter. It will give you value like this: 1.571 into 10 to the power minus 3. And what is TV? Time factor. Use the formula TV equals to pi by 4 u by 100 whole square. Right? That I have told you in the last class. TV equals to how much? Pi by 4 into u by 100 whole square. Find out TV. T is given. So this is the value of CB by S square. Now, when you consider single drainage, when you are considering single drainage at that point of time, TV equals to again how much? CBT by H square, isn't it? Right? Now,
Yes,
TV
sir.
equals to how much? TV equals to, I have told you, pi by 4 u by 100 whole square.
Yes, sir.
By 100 whole square, that is TV, that is equals to CB by H square into T square into T, right? Into T. So from this equation you can find out the value of U. What is the value of U? U will be over here equal to 10%. U will be equals to 10%. Okay. So if the final settlement is 45% At 10% settlement, it will be how much? 4.5, isn't it? So we know rho by rho f into 100 equals to 10, isn't it? So from here you can find out if rho f equals to 45, then rho will be equals to how much? Rho will be equals to 45 by 10, that is 4.5. Okay, so 4.5 centimeter. So what was the statement? The statement was like 9 centimeter was observed because it was considered as the double drainage. Now if it was single drainage, then it would have been 4.5 centimeter. Clear?
Yes, sir.
Yes. Next question. Okay, so you have done the last three only. I will be just telling you all these questions. I'll be solving this. The last one I'll be asking. Okay. So clearly, your 8 meter thick subjected to pressure of, okay, this sum. You have again, if the formula is dV equals to CVT by d square. Here I have double drainage I have mentioned, so it will be H by 2 whole square. TV is being given over here. Time is how much? 1 year. And coefficient of permeability is given next. Okay. And H is 8 meter thick, double drainage. Time will be considered as 1 year only. From here it will be CV equals to how much? You will get, determine the coefficient of consolidation, you will get 3.136. 3.136 meter square per year. Okay. So, hello? Yes? Any issue?
No.
Okay, 3.136 meter square per year. Now, coefficient of permeability is given as 0.04. So, what is the value of MV? We can find the value of MV because we know final settlement equals to MV del sigma into H0, right? And MV equal to how much? MV equals to K by CB gamma W. Someone wrote something from 3 minutes. What is 3 minutes? Sir, voice is breaking from 3 minutes. Just a moment. I check the internet connectivity over here. I believe the intent is still there, Shakir. I think there is a problem with the connectivity, but might be a minor network issue. Okay, you see the PPT.
Now it is okay, sir.
Now it's okay.
Yeah.
Okay. Okay. So MV equals to K by CV gamma W. Okay. Using this formula,
Sir,
you can
till
find
CV I got it.
this.
After
You got
that.
it. Now final settlement equals
Yeah.
to MV del sigma H0 and MV equals to K by CV gamma W. Using K as 0.04, CV 3.136, gamma W as 9.81, you can find out the value of MV as 1.3 10 to the power 1.3 into 10 की power minus 3. 10 to the power minus 3 meters square per kilonewton, I believe. Now put MV in this formula rho F. You find rho F del sigma is 70, MV is this one, and H0 is 8. The value of rho F, that is the final settlement value, will be 0.728. 0.728 meter. Okay, but in the question I have asked you the settlement in 1 year, and in 1 year it undergoes 50% consolidation. See, if the ultimate is this one, 50% will be rho 50% will be how much? Half of this, right?
Yes, sir.
0.364 meter. So first of all, from the basic formula of TV, find the value of CV. Using CV, find the value of MV equal to K by CV comma W. Using MV, you find out the value of rho F, and using rho F, you find the value of rho 50%. Clear? The flow of the numerical? Clear, right?
Sir, after finding MV, we'll put in this equation. Rho F
This
equal
row,
MV
yes.
into gamma
See, from
sigma.
CV you come to this equation, then find MV, MV you come to this equation, find rho F, and using rho F you find rho 50. Okay. PV to
Sir,
get
only but one pressure is given, sir.
one.
Only one pressure is given. We need here sigma, the change in pressure.
Yes, subject to a pressure of, you have to assume that there was no pressure initially. Okay.
Okay, 70 minus 0.
Yes, because I have told you clearly subjected to a pressure of 70.
Yes,
Then
sir.
to consider that initially it was the overburden pressure, change in pressure was 70. After being subjected to this pressure, it undergoes 50% consolidation in 1 year. So this is actually the change in pressure. Okay.
Yes, sir.
Yes. Okay. Next question.
The last point you when again.
Yes. Yes.
Last rho F.
Okay. Okay. Rho F.
Determine the settlement in 1 year, sir.
Rho F is the final settlement. Ultimately, how much settlement it will undergo? Okay, not in 1 year. In 1 year, it undergoes 50% settlement. Clear? Ultimately, that is after many years.
But we use the permeability.
What? Hello?
We use it quotient
What? Hello?
per year.
Yes. Voice is breaking.
No formula we use permeability.
Your voice is breaking. Hello?
Above formula we use rho.
Your voice is breaking, Sharma.
Permeability.
You write down in the chat box.
Sir, only last point you repeat, sir. Last point once again.
Last point is after getting rho F using MV's del sigma H0, rho F is the ultimate settlement. We don't know how many years it will take, but it is the ultimate settlement. Okay, this is the formula for ultimate settlement. I have told in the first question. Ultimate settlement is a function of MV del sigma H0. This is the formula of ultimate settlement. Ultimate settlement is this one. Then 50% of that will be how much? Half of this value. I have asked you settlement in 1 year, and in 1 year it undergoes 50% consolidation. Clear? You have to read this. Actually. You have not read, I think, this chapter or not gone through the problems. That's why. Okay. This is the formula for ultimate settlement, and ultimate settlement we get 50% settlement because it is in 1 year by dividing by 2. Okay.
Sir, my got final.
Your
We
voice
need
is your voice is breaking, Shakir. You write in the chat box first. I'm going to the next question. You write in the chat box first. Okay. Next question is yes. We have to first find out the initial and final effective stress. So number one, initial effective stress will be sigma 0 gamma submerged into centimeter up till the center of the layer, that is 10 meter. Gamma submerged is how much? Gamma sat minus gamma w. Gamma w is 10. 20 minus 10. So 20 minus 10. Question asking settlement in 1 year. But how we came to know that in 1 year only? That is given in the question, right? I have mentioned that 1 year. I have mentioned undergoes 50% consolidation in 1 year. 50% consolidation will give 50% settlement, right? Is it clear now? Yes. I have mentioned in the question only. So you have to read the question very carefully. That is the thing. Okay. So in this question, I am first finding out the basics, finding out the initial effective stress, that is gamma submerged, gamma sat minus gamma w into 10, 20 minus 10 into equals to 100. Initial is 100. 100 kilonewton per meter cube. Kilonewton per meter square it will be. Yes. Now, subjected to a vertical stress increase of 10 kilopascal. Okay. So, this final pressure will be how much? This is 100. 100 plus 10, that is 110. Okay. The first part I have done. 110. The approximate value of the compression index. How to find out the compression index? We have liquid limit given, and it is normally consolidated clay layer. So for part 2, I'll use the formula Cc equals to 0.009. Okay, WL minus 10. WL is the liquid limit. Okay, 60 minus 10 will be 50 into 0.009, it will be 0.45 value of compression index. Now using this you find out the consolidation settlement. How will you do that? What is the formula? Rho or del H, I'll be using del H over here for this, equals to Cc by 1 plus E0 into H log to the base 10. Okay, just a minute. This will be sigma 0. Sigma. Okay. Sigma dash minus sigma 0 dash. Okay, sigma dash we know 110, I believe. Yes, sigma 0 dash is 100. H we know over here, H is 20. Cc we know. E0, how to find out E0? From the basic index properties formula. When it is saturated, it is W, that is saturated, into G, because S will be equals to 1. So what is the value of water content? What is the moisture content over here? It is this one, right? 45%.
60%.
No, 60% is
45.
liquid limit. Yes,
Yeah,
45%.
liquid limit. Yes,
45%
sir.
into 2.7. It will give you, I believe, 1.215. 1.215. Okay. So put these values, you will get the settlement as I think 16 point something, 16.8, 16.82 centimeter. Clear?
Yes, sir.
Yes. I'm going a bit fast because there are so many numericals to solve. Okay. If you have any doubt,
Yes, sir.
after this class also you can join the the next class. Tomorrow I will be having a class. I haven't received any mail
Sir,
yet.
at what time?
Tomorrow, have you received any mail?
No, not
Okay,
sir.
I have received a mail. Wait.
Sir, I will check it. Yeah, yes, sir.
Yes,
We also got.
you got a mail, right? For tomorrow's class, 6 to 7.
Yeah, 6 p.m. 7 p.m. evening.
Yes, yes, from tomorrow's class, 6 p.m. If you have any doubt, you can ask them. Okay, I'll be just going on with the sums right now. So the last one was clear. Now the next sum. Here we have to again use the same
Yes, sir.
formula. TV equals to CB T divided by H by 2 whole square. And why I'm using H by 2? It is in the question only. Sandwiched between a silty sand layer and a gravelly sand layer. Both are permeable soil, right? Silty sand and gravelly sand. So it will be double drainage, isn't it? Both are sand layer, right? Clear?
Yes,
Hello?
sir.
Yes, so it is going to be
Yeah.
double drainage. Hence I'm using H by 2. Okay. Now you have CB given as centimeter square. Okay. Time is given in 2 years and H is given 20. You have to convert entire thing into CG unit, that is
10
centimeter.
minutes.
Yes, centimeter and all those things. You convert that and then you will get time factor as 0.189. 0. Just a moment. It is not responding. You'll get this as 0.1892. Clear? From this, using the formula TV equals to pi by 4 u square, TV equals to pi by 4 u by 100 whole square. You'll be getting u as how much? U as if you get in decimal, it will be 0.4908. Okay, it is in decimal. I'll be giving in decimal only. To find out in decimal, I'll be using u square. U will be equal to 0.4908. Okay. So now, if 0.4908 degree of settlement is equal to 30 mm settlement, okay, so I can say that 30 mm by the ultimate settlement, that is rho f, is equals to how much? 0.4908, right? This is the degree of
Yes, sir.
consolidation. From here, find out the value of rho f. Rho f equals to, I believe it will get 61.12. 61.12 mm. Okay. Now, for 50 mm, you find out the degree of consolidation. How will you do that? 50 by 61.12 into 100, or you get how much? You will be getting, I believe, around 81%, 81.8%, 81
81.8.
81.8 percentage.
8.
Now you have a formula for TV, right? The big formula 1.7813. Do you know the formula for more than 60%?
Yes, sir.
What is the formula? Tell me.
Uh, 0.9332 into log 10 into 1 minus u by
No.
100 minus
TV,
0.
yes, TV equals to 1.7813 minus 0.9332.
Yeah, it has two different formulas. This is also
Yes, the
one
main
form.
formula is one. I have used this formula in this sum, so I'm just writing this formula. You will get in the standard book 1.7813 minus 0.9332 log to the base 10 100 minus u. Okay, this is the formula for TV when u is more than 60%.
U is greater than 60%.
Yes, so using this formula you will find out TV equal to 0.6054. Okay, now using the formula again, T equals to
0.605.
yes 605. T equals to this time factor into h by 2 again, h by 2 whole square divided by CB. H is equals to 20, 20 by 2 convert to centimeter, TB as 0.6054 and CB is given in centimeter square. You will find the value of time in terms of years as 6.4 years. Okay, and I have told you the extra time. So after 2 years, how much time it will take? That is del T. How much it will be? 4.4 years, isn't it?
Yes, sir. Minus 2
Here,
years.
yes, minus 2 years. So for achieving 50% settlement, the entire time taken is 6.4 years. After 30 mm, that is in 2 years, it will take another 4.4 years more to achieve this settlement. Clear?
Yes, sir. Initially, it will take more time. After going some time, it will take less time for the same distance. Year.
Now you can see after it's taking less, for initial 30 mm it is taking 2 years. After that,
Yes, sir.
for 20 mm, that is overall 50, right?
Time.
For 20 mm it is taking more time because initially it has lost the water. After that, the consolidation procedure, it what to say, it slows down, isn't it?
Yes, sir.
It is a gradual procedure. Next question. Yes, in this question you have first, I believe, E and sigma. Okay, E and sigma. So to first find out the value of CC. CC is how much? CC is del E by log to the base 10 sigma 2 by sigma 1, right? This is
Yes,
the
sir.
value of sigma 1 equals to, what is del E? Del E will be how much? You have told this part, the consolidation test 0.6
0.6
to
minus
0.5.
0.5.
Yes, and 300
Divided
log
by
to the base
log
10,
of
300 by
10,
100.
300 by
Yes,
100.
you'll get 0.21. 0.21. From here, after that, you have to find out the initial void ratio. Okay, initial void ratio. Now, for the second part, you have 0.6. Okay, 0.6 and 100. Now, for 150 kilopascal, you don't know the initial void ratio, right? So, use 150 and 100 and 0.6 and E0. Okay, you will first find out del E, that is del E equals to 0.6 minus E0. Okay, and use sigma 2 as 150, sigma 1 as 100. In the same formula you put it, CC, this is CC equals to del E by log to the base 10 sigma 2 by sigma 1. You will get E0 as 0.563. How am I doing this, Shakir?
Yes, sir. Yes, sir.
Yes.
Yes, sir.
So
Zero
this
point five six three.
563 you will get in the same formula.
Yeah.
Okay, initial void ratio. Now to find out the consolidation settlement. How will you do that? It is very easy. Additional stress intensity of 200. Now initially it was 0.563 when the pressure was how much? 150. So del H equals to how much? Cc by 1 plus E0 into initial thickness log to the base 10 sigma
Sir, this
plus
del H or rho F is same, huh?
sorry del H and rho is same. Rho F is the final settlement.
Yeah, settlement.
Rho F is the ultimate settlement. Okay, sigma plus del sigma by sigma. What is sigma? Sigma is 150. What is del sigma? Del sigma is 200 and sigma is again 150. H is how much? 10 meter. Cc is 0.21. E0 is 0.563. Put the values. You will find out it to be almost equal to 0.5. Almost equal to 0.5 meter. Clear? Clear, Shakir?
Yes, sir.
Yes, okay. Please respond, okay, because my net is not stable. If you don't respond, I will think that it has gone, it has gone, okay. Respond when I say. Okay.
Sir, in formula it will be log to the base 10.
Sigma plus del sigma by sigma. That is the final pressure by initial pressure. Final pressure means initial plus change in pressure. What is the change in pressure? Additional stress in intensity. Over here, 200 del sigma. This is del sigma. Clear?
Sir, 200 or 300 it will be.
200, it will be 200 because I am asking to find out the settlement when 200 kilopascal stress in intensity has been imposed. Not this one. This bracketed part is only for the laboratory test. Okay.
Yes, sir.
I am asking you about this 200 kilopascal. So you have to read the question very carefully. In the question I am asking you find the settlement after imposing additional stress of 200. Clear?
Yes, sir. 200 divided by 150, sir.
200 no, 200 is del sigma. 150 plus 200 by 150. Sigma plus del sigma, no.
Okay, 150 plus 200.
What is the value of sigma over here? This is the initial pressure, right? What is the value of initial
Yes,
pressure?
sir.
Given over here,
150.
150. Yes.
Then plus
What is
200. Difference of those two.
what is del sigma? Increase in pressure. What have I mentioned over here? Additional
300
stress.
minus 100. 200.
What is minus? Plus 150 plus 200.
Yes, sir. 350 divided by.
Divide by 150. Okay.
Yeah, yes, sir.
This is only for the laboratory testing part. Consolidation test 100 to 300, 0.6 to 0.5.
It's coming
Which I am using.
0.492.
Yes, that's equal to 0.5 almost. Okay.
Yes, sir.
Next question. At a given site A having this. Okay. So here in this question the degree of consolidation is same. Then TV is same. Okay. Then TV is same. If the soil type is same, then the coefficient of consolidation is same. CV or will be also same. Then we can write like this: time taken, that is T1 by T2 for settlement will be equals to H1 by H2 whole square, because CBT by D square, right? CV is same, TV is same. H1 by H2 whole square. Okay. So what do we need to find out? How much time it will take? Who is joining now? We need to find out how much time it will take. That is T2. So T2 will be equals to how much? T1 into H2 by H1 whole square. Clear?
Yes, sir.
T1 equals to how much? 1 year. T1 is 1 year. What is the value of H2? H2 is 16. H1 is 8. 16 by 2. 2 square 4.
0.25 years.
What is 0.25 year? What are you saying, man? H2 is how much? H2 is 16. H1 is 8.
Oh, I did the reciprocal.
You did reciprocal. No, no. It is 2 square 4
Oh,
into
yeah.
1 4. It is 4 years.
Means inverse of that.
Yes.
4 years,
4
sir.
years.
Inverse, yes, sir.
Yes, 4 years. Clear? So it is 4 years.
Yes, sir.
So it will take 4 years for the site B to undergo the same degree of consolidation. Now, what is the value of rho? It is mv del sigma into h0. Okay. Now, if all the other parameters are constant, what we can say? We can say that rho A by rho B equals to HA by HB, right?
Yes,
Isn't
sir.
it? Same type of soil, same pressure, everything is same. To find out rho B, how do we find that? Rho B equals to how much?
Equal
Rho
to
B equals to rho A
rho
into
A into HB by HA.
HB by HA. Do it, you will find out the value of rho B. If it is 5 centimeter for rho A, it will be 10 centimeter for rho B. Clear? 16 by 8 equals to 2, 2 into have 10. Okay?
10.
Yes, next question. We have solved this for the last 3 questions. Okay, for this we need to first find out the value of E0. The value of E0 will be how much? Saturated soil. So it will be W sat into G. So that divide by S is equal to 1. Moisture content 45%. G is 2.7. We take the value of E0 equals to 1.215. Okay. Now you need the value of CC is given, competitive is given, yes.
Sir, S is here 1.
S is here 1, yes. 1 meter thickness. Log to the base 10, sigma 2 by sigma 1. Okay, you can directly find out, I believe, rho equals to CC by 1 plus E0 H. You will put the value of H as how much? 1000 millimeter. Okay, 1000 millimeter log to the base 10. Sigma ultimate, it is been increment of 20. Sigma final by sigma. Sigma final is equal to how much? 120. Sigma equals to 100. H is equals to 1000 millimeter. CC equals to 0.45.
16.08
16.08. Very good. 16.08
mm.
Yes, very good. Clear? Okay.
Yes,
Good, you're
sir.
catching up. Next question. How to solve this sum? Okay, I'll do it. Everything is given over here. You need to find out rho equals to again CC by 1 plus E0 H log to the base 10 sigma plus del sigma by sigma.
Sir, this last sentence is there, sir. What does it mean, sir?
What does it mean? Increase in vertical pressure is equal to the existing pressure. That is del sigma equal to sigma. That means the numerator will be twice the denominator. Here, if this is equal to this, if this is equal to this value. Are you getting me?
Yes, sir.
Yes, there will be 2, right? Log 2. Simple. Here. Hello?
So it is like 20 minus 10 is equal to 10.
What it is like, I'm saying you the increment is equal to the original pressure. If the original pressure is 10, the increment is also 10, and here
Yes,
is
sir.
also 10. Okay, so the numerator will be twice the denominator, right?
Yes, sir.
That will equal to how much? Log 2, isn't it?
Oh.
You have to catch this. You have to first read the question very carefully and catch this. If you are stuck in this time, you will take more time. Okay, so increase in vertical pressure is equal to the existing pressure. If the existing pressure was 10, increase in vertical pressure was 10, then we get H into log 2. So put the value Cc equals to how much? Cc equals to 0.6. Coefficient we don't need. Void ratio equals to 1.3. I believe you will get the value equals to 314 millimeter. 0.314 centimeter. 314 millimeter. Okay, clear, Shakir? Have you got this?
Yes, sir.
Yes, good. The next question you have solved, right?
Yes, sir.
Tell me. First of all, you have to find out
Sir,
the coefficient of compressibility, AV.
Sir, 3.44 into 10 to the power minus 4.
Yes, very good. How do you solve that? You solve that by using the formula del E by del sigma, isn't
Divided
it?
by del sigma. Yes, yes, sir.
Yes. Del E is how much? E0 minus C. What is E0? 1.068 minus 0.994 divided by 429 minus
429 minus
240.
214.
We put the value, you get 3.44. 3.44 into 10 to the power minus 4. What is the unit? Meter square per kilonewton, right?
No unit. Sir, AV, it is AV. AV has no unit.
AV has no unit. Why it will have no unit? It is in the ratio, it is divided by del sigma. What is the unit of sigma?
It's still in term.
See the
Oh,
formula
okay.
very carefully.
Yeah,
It has E has no unit.
yeah.
Sigma
In sir,
has unit.
for CC,
It will have the opposite unit of
for
sigma, right?
CC, we don't have unit.
Yes, CC you don't have unit.
Yeah, yes.
What is CC now? CC equals to
0.244.
0.244, 0.245 daily divided by log to the base 10 sigma dash by sigma 0 equals to how much? 0.244, right?
Yes, sir.
Yes. What is MV?
1.66 into 10 to the power minus 4 meters
Yes.
square
How you
per
solve it?
kilometer.
What is the formula?
AV by 1 plus E naught.
Yes, very good. AV divided by 1 plus E naught equals to 1.66 into 10 to the power minus 4 meters square per kilonewton again. Okay, now you can find out very easily. You have rho equals to how much? What is the formula? The same formula. I'm not getting the formula again. Cc by 1 plus E0 H into log to the base 10 sigma plus del sigma by sigma. What is the answer you're getting? 18.8, right? Hello?
Sir, I got
What did you get?
something in terms of points.
Point, not in meter, in millimeter. I'm asking.
28.6.
8.6. Is the height of the layer is 8 of 214. Increase in pressure is 214. Okay, increase in pressure is 10, not 429. Is it clear? Del
Yes, sir.
sigma
Yes, sir.
del sigma is 10. 18.72. 18.72. Hello?
Yes, sir.
What have you done in this sum? Cc equal to 0.244. E0 equals to how much? E0 equals to 1.6068, right?
Yes, sir.
What is the height? Height of the sample? 8 meter.
8.
Then log to the base 10. Final pressure divided by initial pressure. What is the final pressure? Tell me. What is the final pressure? Hello?
215.
Why 215? 214 is the initial pressure. I am increasing it by 10 kN per meter square. It is the question. Hello? Hello?
Hello, sir.
What is the increment in pressure?
Sir, 10.
10. Then what is the final pressure? 224, right?
Yes, sir.
Yes.
214 plus 10.
214 plus 10 by 214. In that way, you will find out 18.8.
Yes,
Okay.
sir.
Okay. Next question. Have you done this one?
Sir, in previous problem,
Yes, yes. What?
sir, it is given first this pressure is increased to 420.
Leave that. I am asked you to find out the settlement. Read the last part of the question. This one you have to read the question very carefully. Find the settlement of foundation resting on the above soil if thickness of the layer is 8 meter and the increase in pressure is 10 kilonewton per meter square. The void ratio
Sir,
specimen.
now my question is, sir, if we
Yes.
increase more, then it is.
Hello. Repeat the
If
question.
we increase, sir,
Your voice is breaking. Right in the chat
but
box. Right in the chat box. Okay. Okay, you got it. Okay. This question you have solved, right?
yes, sir.
What is the answer you have got for 400 kilopascal, 800 kilopascal?
Sir, sir,
Your voice is breaking. What I am doing over here, I am taking this one, this thing. K, log to the base 10. I got same answer 2 centimeter. No, it won't be 2 centimeter. Just a moment. Okay. So in this thing, you see, Cc by 1 plus E0 into H will be same. Okay. So this I am taking as K. So K will be equals to how much? Del H by log to the base 10 sigma by sigma 0. Sigma is initially 200 by 100, so I will be writing it here. Del H by log to the base 10 sigma by sigma 0. Del H equals to how much? Del H equals to 2 centimeter and sigma is 200 and sigma 0 is 100, you'll get the value of 6.644. Now you have to put the value del h1, that is increment to 400, will be equals to how much? K log to the base 10 del sigma by sigma 0. K log to the base 10. What is the value of final pressure over here? In the first case it is 400 by initial pressure was 100. You will get the value 4 centimeter. In the same way, del h2 equals to k, same value of k log to the base 10. It is 800 by 100. You will get 6 centimeter. Okay, clear? Just solve it in this way, you find the answers. Alright, Sakit?
Yes, sir.
Just a moment. Last question. Have you solved this question? What is the answer you have got for del E, change in void ratio?
Not this one. I didn't.
You told you do the last 3 questions.
Accepted this. These 3 questions I did.
Last 3 questions you did, right?
हाँ.
ऊपर का 3 questions किया था 14, 15, 16. Your voice is breaking. Okay, anyway, I'll be solving this. Sigma by sigma 0. Cc I think is given 0.28. Sigma is 12 and sigma 0 is 12 and sigma is 21.6 given. Solve this, will get the value of 0.0715. I'll just check it. Yes, and then you can find out the value of h, that is del h. So how much? Cc by 1 plus E0. Cc by 1 plus E0 into h. Now Cc by 1 plus E0 h into log to the base 10 sigma by sigma 0. Another way you can write the formula, since you have already found out del E. Cc log to the base 10, this one is del E, right? So this one can also be h into del E by 1 plus E0. Now h is 6 meter. H is 6 meter. Del you have found out, and 1 plus E0. E0 is 2.05. You will get, I think, 0.141 meter. 0.141 0.141 meter. Clear, Shakir? Hello? Is it clear? Am I audible? Yes, first we'll find K and put the same formula. Yes. The last question. Okay, so I believe I have solved all the question. You can find this in the Google Drive and also in the YouTube link if you have any doubt. And if you have any doubt, there will be a class tomorrow also, Shakir. Isn't it? There's a mail. You got the mail, right?
Yes, sir.
Yes. Tomorrow also there will be a summary session. I think I'll be framing some questions. There will not be any numerical questions, only MCQ, which with which we can discuss the main concepts of the chapters we have read. Okay, clear?
So from all chapters.
Yes, whatever the chapters that have been covered in the 12 weeks, the live sessions of 12 weeks,
Yes. What?
from those chapters, I can do that. I'm not sure what will I do. I can frame some MCQs which we will be discussing to understand the concept in a better way. Tomorrow from 6 to 7. Okay? Is it clear, Shakir?
Yes, sir.
Okay.
Yes, sir.
Okay, Shakir. Okay, you haven't solved any questions today, but it was an interactive class overall. Thank you for attending to the class. I'll see you tomorrow. Is it?
Yes, sir. Yeah.
Okay. So tomorrow is going to be the last class, a summary class. Please attend the class, and we'll be having some discussion. And any topic you have in mind regarding this session, live session which you have covered, if you have any doubt, you can ask me tomorrow. Okay.
Yeah.
Okay, Shakir, it's okay. Your voice is breaking. Okay, good evening. Then, bye bye. You got new things. Thanks a lot. Yeah, you're welcome, Shakir. Thanks for being there in the class. Okay, bye bye.